Hi everyone, welcome to Digital Worlds, KNB137. Let's get started. Hi, my name is Mohammed Hassan Faramarzian Borajani, so you can call me Mo Faramarzian, right? I'll be your lecturer and tutor this semester. Who am I? Basically, I started my career, which is roughly 14 years ago, as a 2D animator in Marvel the Wonder Chicken. And then I moved on to games, did cinematics for games, and then I worked on asset creation and some novel interactive experiences with Marvel. And now here I am. So, what's the focus of this unit? So, we're going to explore fundamental practices of real-time computer graphics. Um, we're going to use real-time graphics to basically produce movies or very cinematic looking experiences. So how are we going to do this? We're going to be using Unreal Engine 5, which is a game engine, but we're just going to call it a real-time engine because um, its use is not singular anymore. It's being used for cinema. It's been used to create movies and products and also games. So we're just going to call it a real-time engine. But to use this real-time engine, we need to really abide by the laws that govern using real-time engine. They're a bit different, and the process is a bit different from using a software and just rendering within a software, which we'll go through this lecture. So what is real-time? Real-time is when user views a frame that is rendered by the computer and you can interact with it. So it receives an input and the process is changed and we display the frame instantly. So whatever changes we make by moving the camera or changing daylight or whatever, it's reflected back to us exactly in real time. Well, not exactly by 4 milliseconds, but still we call it real time. Whereas in the older methods, we had to wait for rendering to be done. For example, in this uh, video here, I'm going to demonstrate to you how rendering works.
Having
So
troubles
when
going
you're
from this to this? Your animation is finished. You have everything done. Composition checked. Lighting checked. Materials checked. Now you want to render your animation, but wait, you have no idea how to set up your render settings. Let's fix this today. Having trouble.
So back in the day, you had to basically set up your render. You had to change settings and things like that, and just press render to go from what you see here to something that looks a lot more presentable. But with real-time engine, you still change the settings, but you see it feedback in real time. So if we go back in 1992, when the first games came out, they could only render this much to show you in real time. Anything more than this would take a lot of computer power because real-time render engines are really heavy on the resources that you have available on your computer. They need strong graphic cards and strong CPUs. So MacBooks and the sorts, as it still stands, can't really utilize Unreal Engine 5. So now, today in 2021, which is 2023 right now, games are looking like this. So we've come a long way. And for that, we need a lot more power to run them. For example, they've tried to use real time in production of animations as well. Not in the same sense, but it is still a step towards real time. I'm going to show you a clip from Pixar Animation in the creation of Finding Nemo, where they've developed a system so that the animators could really see in real time what is happening within the scene they're animating. Because back in the day, they wouldn't be able to see it played back. They would have to animate and wait a week while it rendered and come back and say, oh, well, that doesn't look good. I got to change something here. So this is what advances have been made by 2017, which looks like this.
Production. It's going to be presented by Dirk Van Gelder.
Thank you very much, ladies and gentlemen. It's an honor to be on stage with all this great real-time graphics that you're going to see tonight. Now, I'm going to start out with some final rendered frames from Finding Dory. Each of these frames takes dozens of hours to compute. And our artists do a lot of presentations about what it takes to generate these pixels. But what we don't talk about is what it takes to what the artists see, the real-time pixels that the artists see while they're working. So I'm going to start this out by showing you, by loading that same shot into USD view. Now check out how fast this loads. What I just loaded was, we're looking at 80,000 meshes being drawn with 52 million polygons, all at real-time frame rates. Now what's happening here is our USD architecture is streaming all of this geometry off disk and loading it into memory, including this grass simulation, and then the Hydra OpenGL render that's integrated into USD is then drawing all of this geometry in real time. Now, we're not just blasting images. Hydra is drawing all of this geometry at whatever we're seeing down here. We're seeing 60 frames per second, Hydra drawing all of this geometry. I want to try one more thing. Let's load this again. How fast does this take to load? Let's count it off. 1, 2, 3. 3 seconds for 52 million polygons, which I think is pretty good.
If we move forward here, we can see some more camera effects that can be added to
awesome.
Seeing
now,
in real time.
I think this is also working. I'm going to show you an integration of USD into a DCC app, in this case, our Presto animation system. So here, USD is reading all of that coral off disk and displaying it. Hydra is drawing everything that you see in front of you. And we've got a couple things we can highlight. For instance, we can turn off some of the lighting effects. We can maybe move out here and turn off some of the depth of field, turn off hardware shading, turn off some of the ambient occlusion. Now this doesn't feel interactive, it doesn't feel underwater. It feels like a bunch of hard plastic, and it's hard to sort of feel like you're immersed, if I may say so, inside the shot that you're trying to do. So if you turn on depth of field, now you can see what your lens is trying to do. If we play, you can see the real-time caustics and lighting effects that really make it feel like it's.
So as you saw, they were able to make an engine that kind of works in real time so that they really feel immersed in the scene that they're about to animate and make sure that it really looks the way, as close as it would to the final result.
Underwater.
Also, they've moved,
I want to show you one more guy. You'll probably recognize
for the movie Cars, I think it is. They were able to put reflections in as well to just see how that final result would look. So they can work on close to the final, as close to final as they can get.
You can make him look angry. You can pull him down into mad face, pull up the jaw, maybe bump out a sneer, pull out the lower lip and make him look mad. This is animation at Pixar. This is 60 frames per second, physically based GLSL, full production rigs in Presto. And I also think when you go back to work on Monday, please take a look at Universal Scene Description. It's awesome, it's free, it's fast. Download it, check it out. Thank you.
So now you see how necessary real time is for artists out there to kind of be able to see what they will get. So this is called WYSIWYG. It used to be part of web design. Is what you see is what you get. So as artists are able to work on something and see exactly the results instantly, it can make them be able to have more creative freedom on how they want the final product to look. So going forward, this is for those of you who are squeamish, maybe you can skip this part, but this is Love, Death, and Robots Volume 3, which was basically made in Unreal Engine and really pushed the boundaries of what could be accomplished. I'm just going to show you a clip here to kind of make you understand how different Unreal Engine production is. So here they talk about the funding they had. They had to keep a portion for rendering, but since they're working on a real-time engine like Unreal Engine, they didn't have to have that budget, so they spent most of it on the assets that were necessary for the film they were making. So let's have a look at this.
In a year, even though we had no prior footprint for Unreal at the company, it was a leap of faith. It's going to be hard. There's no roadmap. There's probably no parachute. I love those kind of challenges. I love going into a project where you are lucky. What I found to be really exciting about this workflow was the fact that in pre-production, when you're building assets that you're going to be using in layout, those are the same assets that are going to end up in the final piece. They just get progressively better through the process.
We built an entire 15-minute piece as a framework to work from within 2 weeks. Next step would be to take that up and sort of raise the level of the entire piece all at the same time, right up until the shoot.
We were showing blocking. We actually got feedback from the clients. They're like, did you spend all your rendering budget on your assets already?
Working inside of Unreal flips the script a little bit. Our asset artists become world builders, and they are able to pick and choose from the Quixel library or other libraries that we have available. The fidelity that's available to you at the click of a button, it's incredible, it's amazing. And it allows ideas to happen organically, and you can explore.
You're just not focused on turntables anymore. You're seeing things live in the shots as they are meant to be, and you get swept up in the story, you get swept up in the capacity to change it and shape it. It's pretty liberating.
The performance capture process, we prepared Unreal assets that could be played on monitors, tracked with the camera in real time, where then the actors could then see themselves in the body of their avatars. And then they would know, as they're walking through a tunnel, for instance, the curve of the tunnel. They actually will maybe crane their head and kind of peek around the corner. But on the set, what they're really seeing is just a bunch of poles indicating the volume of the tunnel. And that's vital for helping performances. Usually it takes a week or so before I can get the data. I have to actually order the data and be very specific about which takes I like so that they can process the body motion capture first, so then we can begin the process of doing layout.
Normally, we try to make our first edit with cuts from the video footage, which is this mix of 2D storyboards and video footage of actors running around on a soundstage with tights. And it feels a million miles away from what your project is going to look like. With Unreal's involvement, you get the take recorder clips almost right away. You've got characters interacting in your environment, and you can place cameras on them. You get the eye lines figured out, what your cutting pattern looks like, and that's going to inform how you make your mocap selects. Now you're making your cut with footage that looks like the footage in the final project.
We can't say enough about metahumans. The project was very ambitious. It was doing 6 characters, human photorealistic characters in engine for 15 minutes short, all of them with dialogue, many of them with various degrees of mutilation and complexity.
In our early discussions with Epic, they showed me an early version of the MetaHuman demo.
So there you have it. Not only does it change how budget is spent on a animation project, it also changes the role. As they said, the asset creator becomes a world builder. Also, the director doesn't have to, shoot with a manual camera people in like spandex, and they can actually use the footage from Unreal to cut together the animation to kind of see how it looks so that they can go to full production. So as you can see, working with real-time engine is a bit more different, which is what we'll be going through this semester. So not only do they use it right now to create shorter animations, but now it's being used for creating things, shows like The Mandalorian. The Mandalorian uses this technology to kind of create the backdrops for the character, not the entire show, but the backdrops that usually get shot on green screen and then put digitally, but this time they can do it in real time, and that helps them to light the scene as well. Our unit coordinator, Paul Van Optenbosch, also has set up a very similar technology in the labs at C9. So let's go have a look at what this technology is.
Part of what's been fun about collaborating on The Mandalorian with Lucasfilm and Disney is that we have been able to see through a few technical innovations and a few firsts that I think are going to have a lot of impact. Technology coming together to create a backdrop for the big, beautiful world of Star Wars.
The volume is 21 feet tall, it's 75 feet in diameter, run by 7 machines, pumping the visuals onto the screen that's been created in pre-production and can be on the screen within 24 hours of being finalized.
So that there in the background is all LED screens that show an environment.
It's incredibly impressive when you first walk out there because it completely surrounds your peripheral vision. And you really quickly forget that you're indoors and you're not out on some planet's surface. It feels like a real three-dimensional environment surrounding you because it is a three-dimensional environment.
You can allow your key creatives to all make decisions together so that the shots are captured entirely in camera, which allows for a better performance.
And what was so exciting about this is by bringing those people together, things started to click. And we started to realize, well, let's not just do green screen and interactive light. If we're going to design the whole set and game engine ahead of time, maybe we could have some in-camera effects.
Everything in the volume is designed to both light the actors and to be a background that we can directly photograph. So you end up with real-time final pixels in camera.
If you look at visual effects, heavy films, you've got a film set and then it's going to go to post and it's going to get the world put in. Here we're considering all of that at the same time, and how do we create a background and foreground that live together on the volume harmoniously?
When we started to play with the idea of using Unreal Engine for virtual production, that's one of the things that Richard and John started to embrace, is that you've got this very dynamic world where you can have randomization of things and find the happy accident that gives you the perfect shot. Being able to see the actors point at things and see what they're looking at was pretty transformative. It gave everybody context, with the added benefit that if you want to move a mountain from there to there, you can do it instantly.
You could switch between the Iceland location to the desert location, all within the same day of shooting.
The ability to shoot a 10-hour dawn is extraordinary. To shoot any sequence where you say, oh, this world's not quite right, let's just move it a little bit. An extraordinary number of benefits and advantages for shooting in that environment. It's mind-blowing what that tool is.
What you see is really what you get. And that's something that really means a lot to filmmakers, especially those who have worked with a more traditional.
So there you have it. What you see is really what you get. And that's the beauty of Unreal Engine 5. So let's go on. And basically, Unreal Engine is not just for movies and film production. Also, a lot of people are starting to use it for fashion design. They're using it for product design as well, because so quickly you can iterate and change different things that it just becomes a better tool to kind of put in your workflow to get results fast. So let's talk about your assessments. So these can be accessed if you go to Canvas, and the first page that you'll see when you click on KNB137 is you have your timetables, you have your assessments and things like that. So when you click on assignment, that's for submitting the assignment. But when you're on the first page when you click on your KNB137, down there you'll see assessment. So click on that and you'll see an introduction, press next, and go through what you'll be asked to do. So let's go through it over here. So I really urge you to come to all the workshops, because that's where you get time to use Unreal Engine 5 and really work on your projects. And I'll be there. If you have any questions and need help, I can address those as well. So this really centers around your exploration of the practice and the theories of production of a real-time application. So these considerations really impact real-time environments and real-time assets as well. What we are going to do in the first assessment is something that's very close to my heart, which is Indiana Jones. There's a scene that there's an altar and there's an idol on top of the altar. So for this altar, we have assets that are ready made in using Quixel Bridge, which we can use to really decorate the scene. But what you will do is basically go through the modeling of this altar, this idol, and the idol is basically based on a movie where the sun comes down and there's a beautiful light on there, and it's really popping from the frame here. That it looks important, and it's very different to whatever is around it. Making sure that when people look at this scene, that they know that this object here is the most important in this scene. And that's what I really want you to be able to engage with as well, to build a scene that supports your focus, the asset in focus. And this asset in focus is something that you'll be modeling, texturing, and bringing into Unreal. So it's based on a dyadic kind of design. You'll be modeling the head and texturing it in Substance Painter, and then bringing it into Unreal Engine. And then we're going to light it and have that as your first assessment. So definitely you'll have a lot of these real-time assets in access to these thanks to Quixel Bridge, and also you have very predefined collection of real-time assets as well that really bring your environment together. And also I really want you to document everything you do on a blog. So whether you're using the Adobe blog system, I'm not sure what it's called, or as well as sites.google.com. So if you go there, you can make a blog very easy. You can just create a new and just drag and drop photos in there and start making a diary of everything you go through when you're doing these projects, because that's what you will be submitting to me. You'll give me the link to that blog with everything you went through. I don't want to see this created right at the end when you finish. I want to see you updated weekly as you're going through creating this, the problem you're facing, what you did right, how did it look for the first time you modeled it, and as you iterated it, how did it change. I want to see these things. So make sure that you do document them and keep them on your blog. And then at the end, when the assignment is due, I want the link to that. So assessment 2, it just expands on the first one. So we're going to build an environment and some characters as guards to this environment. And this environment, it should really enhance the presence of this idol. So this idol is the most important thing here, and the environment should really reflect that. I really want you to think about where things grow, or the dirt, or whatever ideas you have, where some assets should be put, and how not to clash with your main focus, which is the idol. So going forward, you'll have to create a cinematic towards the end, which definitely I'll guide you through on how to render an animation and set cameras and everything. But I do really want to reiterate that you have to keep a diary on your blog. What you can do is save images and everything, which I'll run through in week 2 and show you how that's done as well. And I look forward to working with all of you and see what you can come up with. So definitely the lectures will cover theories and assessments and methods also. So I'll have sections there where I show you how things work. The workshop is where we try to implement whatever we've learned in the lectures, and to create your assignment and your assessment. And I'll be there for feedback if you need me. And I really want you to engage with these lectures and watch them, because I'll be putting a lot of time into them for you to learn everything there is to know about what you need to complete this assessment. So power to you, and I'll see you next week. Okay?